Hello guys, my name is Tu. So for this video, I'll be talking about plant simulation software from Siemens PLM, which is for production simulations to improve the production throughput by changing the parameters and varying the production settings and all that. So currently it is showing two AGVs carrying the parts. So I have some station which is test A station, test A stations. These trees are test A station, these trees are test B station, and these two are test C stations. So the AGVs will go to the source location to pick up the source object. So this is the source location. We can see that currently the source will follow. We input the product according to the table production schedule here. For example, firstly, it will input 4 parts with the part number 1. Then once this is input, it will continue with the second row to input 4 parts of part number 3. Then 4 parts of number 11 until the end of the list. Once the list is completed, it will try to input starting from a beginning, because it will try to maintain a cyclic manner to input continuous product into the simulation. So we can also change to a sequence. That means once the list is completed, then the simulation will stop. So for now, we're just going to use this for demonstration purpose. So moving to the other side, we have this sequence table. The sequence table will determine the sequence of the station according to the product number. For example, for product number 1, it will need to go through station test A, following with station test B, but not test C, because there is a 1 here indicates yes, and 0 indicates no, do not go to that station. So based on the product number, it will have different combinations of sequence. So there are 2 tables which is important for this simulation setup, and obviously this does not come in the standard package of the software, and customization is needed. So when we talk about customization, some of the new user of plant simulation would get discouraged because they think that the coding is requires additional learning curve to learn the coding before they can write the custom behavior and so on. So this video is just how we encourage the new user of plant simulation to use plant simulation even though they are not familiar with the coding and the customization process. So how can we? So for this video, I'll be demonstrating to you on that. How can we help the new user to develop something like this using a template model? So I will stop the simulation now and close everything, because I'm trying to start from the new user point of view, creating a new file. So let's go ahead and create a new file in 2D. And we'll immediately initiate the 3D because the template has the 3D information. Then once it is initiated, we'll import the template into this new file. So we'll go ahead and right click at the class library and choose load objects. This will be the templates. So we'll just open here and we'll replace all the existing objects within the standard libraries. So this will be the templates. So for example, if I double click this template, this will be the representation in 2D. This area, this rectangle area, represents the design space where the station will be put. So the users can try to put in the station themselves through the available stations here. For example, I can just drag and drop test A station 3 times to this location. Then I can drag test B 4 times. So the user can do it themselves, where to place test station, and so on. For example, I can just drag a test C station 2 times here. And finally, test D just represents the drain object. When the product has completed, the product will be carried by the AGVs to the test D or the drain object. So the AGVs will enter the field from the worker pool here, so they can walk through the walk path into the design space and carry a product from the source object. So now let's go ahead and open up the 3D view. So this will be the 3D. So the 3D layout is according to the 2Ds. So we can try to do a quick check on the obstacles. For example, we can show the obstacles area which is bounded with in red color. This obstacle means that the AGV shall not pass the red color's boundary, so it will create some obstacle for the AGVs to move freely within the design space. However, because we see that there is, even though there is an opening here, but the red color boundary is still here. So for this purpose, we can create some additional footpath which is hidden at the bottom of the floor objects. So that footpath will allow the AGV to travel across the boundaries to enter into the design space. So now let's try to, so currently in the worker pool, we have input 3 units of AGVs into the field. So we can always change the amount of AGVs here. For example, if I change to 4 units, so the total of units entering will be different, and we can try to play around with the different combination and see the different scenario. So now let's go ahead and click and start the simulation. We are starting the simulation in a real-time manner. So currently 1 AGV has entered the field and moved to the source object, and depending on the source object and the source part ID number, so the part number 1 we need to go through a different series of stations and so on. So we can try to run a quicker simulation, for example with 3 times the real speed and so on. So this video demonstrates how easy it is, so that the new user, even though they do not know how to do the custom scripting or programming using plant simulation, so they can still use the template and then do some simple drag and drop to place the test station, so that the AGVs will still move to the station and do the jobs according to some customized behavior. So that's it for this video. I hope you enjoy it. Thank you very much.